Okay. Sandali ha. Yan, do not disturb ko lang yung aking device. So A elements A and B are conjugates in G if there exists an element X in G for which si A can be written as XB X inverse. In other words, if you can find an element when multiplied to the left of one and its inverse on the right gives you the other element. Okay. Um, so this theorem specifically tells you when are two elements in S sub n conjugates to one another. Bakit S sub n ang tinitignan natin, sir? Kasi, di ba sabi nga natin, sabi ng K-list theorem, lahat naman ng group basically are embedded within S sub n as a subgroup. Parang ganon. Kaya, ang tinitignan na lang natin ay S sub n in general. Kumbaga, S sub n can speak for all the other types of group. Okay? Nasagot? Because elements in S of n can be written or may tinatawag tayong cycle decomposition, di ba? Kapag meron kang permutation. When you look at the cycle decomposition, if they have the same type, ibig sabihin, kapag masasulat siya in terms of 1 3 cycle times another 4 cycle, dapat kung conjugate sila, ganun din yung kanyang cycle decomposition. Maaring iba yung elements but dapat ganun din yung type. For example, ang isang 3 cycle hindi pa pwedeng maging conjugate sa isang 2 cycle. Di ba? Ano pa? Ang isang etc. No? Meron nga ako ditong example. I think naputol tayo dito last time. So we are going to calculate pi, alpha pi inverse for this value of pi and alphas. Yung alpha iniiba-iba and then yung conjugating element, yung pi, ay fixed. No? So paano ginagawa ito? So let's do number 1. Did we do this? Ano yung huling ginawa natin? Can you please remind me?
Wala pa po.
Okay, wala pa. Okay. So we will do this one by one. So let's begin with the first one. Kapag sinabing pi, alpha pi inverse, it's just pi, ito yung cycle mo, pi inverse. According to the proof of the previous theorem, there is a way to do this conjugate, no? Napatunayan natin na kapag k-cycle ang isang element, ang mga conjugates niya, mga k-cycles din. So, ibig sabihin, dahil ito'y 4 cycle, ang conjugate na ito, kahit na ano yung pi na yan, actually, will also be a 4 cycle. But which 4 cycle is that? According to the proof that we have presented last time. Kaya mahalaga nagbabasa ng proof. Kasi sometimes yung kung paano mo gagawin yung isang bagay, ay mababasa ninyo doon sa loob ng proof. Sabi dun sa proof, you just need to evaluate pi at each of the n element in the cycle. No? I-evaluatein mo lang si pi doon sa mga nandoon. Then you just form that 4 cycle again. So in this case, yung pi of 3, well, technically, yung mahaba talaga, alamin mo yung inverse ng pi, alamin mo yung cycle na to, ito yung mahaba, di ba? Yung mahabang version, lalagay mo dito yung pi, tapos kukunin mo yung cycle na yan. Yung cycle na yan, paano kino-convert? 3, 1, 4, 3, 1, 4, 1, 4, 2, tapos 2, babalik sa 3, tapos yung 5 na fix. Tapos yung pi inverse, i-inverse mo si pi. So 1 will go to 3, 2 will go to 1, 3 will go to 5, 4 will go to 4, 5 will go to 2. Tinitignan mo yung pataas. Pataas tayo pag inverse, di ba? Yan. Tsaka mo i-multiply. Ito yung mahaba. Ito yung manual version. Pero tinuruan kayo ng proof to do this in shortcut, no? Ano yung pi of 3? When you look at this, the pi of 3 is 1. Kaya lalagay mo nandito 1. pi of 1 is 2, diba? So 2. Pi of 4 is 4, and then pi of 2 is 5. So the cycle 3, 1, 4, 2 as a conjugate 1, 2, 4, 5 by the element pi. Pero kung gagawin mo yung long method, kagaya nito, mag-multiply ka ng tatlong permutation pa, di ba? Ang dami kang gagawin. So we do this 1 to 3, 3 to 1, 1 to 2. Lalagay mo dito 2. Di ba? Tapos dito 2 to 1, 1 to 4, 4 to 4. 4. Next, 3 to 5, 5 to 5, 5 to 3. That's 3. Next, 4 to 4, 4 to 2, 2 to 5. Finally, syempre, natitira 1 na lang naman yan. So kung mapapansin nyo, it is really the cycle 1, 2, 2 to 4, 4 to 5, 5 going back to 1. As you can see, parehas lang naman yung lumabas na sagot. No? So actually, whether you do this or you do this, wala namang problema. No? Kaya lang yung proof ay nagbibigay sa inyo ng other options. So whichever is saan kayo mas comfortable, pwede niyong gamitin yan. Naintindihan niyo yung point ng example. You don't have to do both, no? Both method. Mamimili lang kayo kung ano yung mas convenient para sa inyo. Kasi for me, yung una, yung putting method ang aking preferred than the manual. Ito yung original na, ito yung by definition, di ba? Ito yung by the proof in the theorem. So whichever is your preference, it doesn't matter as long as you come up with the correct answer. Naintindihan nyo? You don't have to do both. Pero kung mamimili kayo, ano ba, kung ako mamimili, I would prefer the first one. Do you understand? Okay. So let's proceed with number 2. Paano yan, sir? Dalawang yan? Cycles to si alpha. Product na siya ng dalawang disjoint 2 cycles. So papaano na to? So technically ganito siya, diba? Pi 3 to 1 times 4, 5 is pi inverse. Now the trick is you can insert, for example, you can insert pi inverse here. Now to counter the effect, I will multiply an alpha. I know a pi, sorry. Kasi by doing so, identity lang naman to, diba? So it cancels. It has no effect. But then by introducing this factor, kinonjugate mo yung 3 to 1 by pi, kinonjugate mo individually yung bawat cycle. So yeah, apply ko yung technique just like before in each one of the cycles. So for the 3 to 1, anong conjugate niya? I-apply mo si pi. Pi of 3, pi of 2. Ang dali ha. Pi of 3, pi of 2. Ano pa? Pi of 1. Ano yung pi of 3, pi of 2, pi of 1? What is that? Pi of 3 is 1. Pi of 2 is, sorry, hindi pa tayo tapos. Yung second na cycle pala, that will be pi of 4, pi of 5. So ang pi of 3 ay 1, ang pi of 2 ay 5. Saan ba nakikita ito? Dito sa definition ng pi. Okay? Then pi of 1 is 2. And then finally, pi of 4 is 4, pi of 5 is 3. So the conjugate of alpha is also a product of 1 3 cycle and another 2 cycle. Sabi ko nga sa inyo, sabi nga sa theorem, dapat same cycle type ang conjugate ng bawat element. Did you understand this example? Okay, let's do the last one. So for the last one, alpha is written in the original notation form. Now, so how do you get its conjugate? Remember, this formula or this rule applies only when your permutation is already written in the cycle decomposition form. So the first thing to do to apply this technique, you have to write first alpha as a product of disjoint cycles. So how do you write alpha? Sige nga, can you write alpha as a product of disjoint cycles first? What is alpha? Can you give me the factors, the cycle factors?
1, 2, 3, 5, 4.
1, 2, 3, 5, 4. Kasi ang 4 babalik na sa 1. No? So basically, alpha is a 5 cycle pala. Di ba? Yeah. So because alpha is a 5 cycle, its conjugate by pi is also a 5 cycle. Indeed, if you do pi alpha pi inverse, ang ginagawa mo lang, kukunin mo lang yung cycle by evaluating pi to each one of these elements. Di ba? Natin. Okay. Pi of 1 is 2, pi of 2 is 3, pi of 3 is 5, pi of 5 is 4, and pi of 4 is 1. So the conjugate is 2, 3, 5, 4, 1. But let's say I wanted you to write the answer in this form as well. Kung gusto nyo lang, di sulat nyo lang. Paano yan? Si 2 pupunta sa 3, si 3 pupunta sa 5, si 5 pupunta sa 4, si 4 pupunta sa 1, at si 1 babalik sa 2. So just in case you would like to express your answer this way. But ako, I always would prefer the cycle decomposition form. Yung ganito, rather than writing this kasi this is more compact. Na hindi, you don't have to write in 2 rows. Ito isang row lang. Nagkakaintindihan na tayo kung ano yung permutation, di ba? So, but again, it's just a matter of preference. Wala naman akong nire-require unless i-require ko. Okay? Do you get this example? Okay. And another example. Ito naman, you are asked to find a permutation pi so that pi alpha pi inverse is sigma. Ito yung alpha, ito yung mga sigma na possible. So this time ang hinahanap yung pi, yung pang-conjugate. Okay? So alamin natin yung pi so that these two are conjugates. Ano ba, alpha and sigma are conjugates. Ano yung nagko-conjugate sa alpha para maging sigma? So we are now looking for those. So first of all, tignan muna natin kung conjugate nga ba sila or kung meron bang, is there really such a thing as pi? Baka mamaya wala. So in order to know, you have to decompose alpha and sigma in cycle decomposition in terms of disjoint cycles. So for alpha, in terms of products of disjoint cycles, it is 1, 3, 4. It's a 3 cycle. 2 is fixed, diba? Now for number 1, sigma is, if you write this in disjoint cycle form, 1, 2, 3. So it's also a 3 cycle. So technically, they are conjugates, di ba? Alpha and sigma are actually conjugates in SR form. So sino yung nagko-conjugate? Question mark. So sino yung nagko-conjugate kay alpha para maging sigma? Ang gagawin nyo lang, you're just going to find, take pi to be the permutation such that kailangan ipapadala ni pi si 1 kay 1, si 3 kay 2, si 4 kay 3. So, ang gagawin ng pi, dapat si 1 pupunta sa 1, si 3 kay 2, at si 4 kay 3. Siyempre, wala ka namang option dun sa natitirang element. Aside from 4, kasi wala namang ibang element ng pwede. But in reality, possible na maraming pi ang lumabas. Kaya lang in this example, nagkataon na unique yung pi. Kasi wala ka ng option dito sa 2 eh. We don't require anything sa 2, di ba? Kaya lang, dahil napuno mo na yung tatlo, isa na lang naman yung lalagyan mo. Wala ka ng option kasi the permutation has to be 1-to-1 and onto. Pero for example, kapag ikaw nasa S sub 7, halimbawa, kahit ano lagay mo dito, sa 5 kahit na ano, sa 6 kahit na ano, sa 7 kahit na ano. Kaya hindi necessarily unique yung pi na mahahanap mo. Nagkataon lang that in this example, such a pi would be unique. Did you understand? Ay, actually, hindi rin pala. Kasi another way, do you remember itong 134? Ay, pwede rin isulat ng 341. Do you remember that? Right? So, another way to find a pi is to have a pi that sends 3 to 1, 4 to 2, and 1 to 3. Eh, pwede mong yun ang i-require sa pi. So, in other words, hindi talaga isa lang yung pi na possible. That's the thing about it, no? Hindi unique yung pi in general. Yeah. So if you take this pi, as you can see, si pi, alpha pi inverse na yon will automatically be sigma. Hindi nyo na kailangang i-check, alam mo na yon na based on our computations before. Okay, so let's take example number 2. Again, alpha is the 3-cycle 134. On the other hand, sigma, when you write it in the cycle form, this is 1, 2. Sasarado ko na kasi 2 bumalik na sa 1. And then si 3 gumagalaw pa. So, susulat mo pa 3, 4, and then 4 back to 3. So this time, sigma is a product of 2 disjoint 2 cycles or transpositions, if you may want to call this. So therefore, alpha and sigma are not of the same cycle type. Diba? Alpha and sigma are not of the same cycle type. Kung ano man ang isipin natin ng cycle type na yan. Kasi itong nauna, si alpha ay 3 plus 1. Ang isipin ko ng 3 plus 1, yung tatlo umiikot. May 3 cycle ka, tsaka may isang element na hindi gumagalaw. While sigma is a 2 plus 2 type. When I say 2 plus 2, dalawang 2 cycles. Did you understand? Yung notation ko na 3 plus 1 tsaka 2 plus 2. Okay. Yeah. So, ano conclusion about alpha and sigma? Because they are not of the same type, alpha and sigma are not conjugates. In SL4, therefore, no such pi can exist. Hindi ka makakahanap ng pi na makakapag-conjugate sa alpha to get sigma. Kahit anong gawin mo. Kahit itest mo pa lahat ng 24 elements nung S sub 4, isa-isahin mo, no, it will never be a conjugating element for alpha to get sigma. I hope naintindihan niyo yung example na ito. Do you have questions? Meron ba tayong tanong? Okay, let's move on. So remember, being conjugates is a form of an equivalence relation. Therefore, ipa-partition nung equivalence relation yan, yung group natin into equivalence classes. Magkakasama sa isang class yung mga conjugate sa isa't isa. Di ba? Ang tawag natin doon sa mga equivalence class na yun in this case are the conjugacy classes. Okay? So the question is, how many conjugacy classes are there in S sub 3, in S sub 4, and in general in S sub n? How many, parang ang tinatanong natin basically, how many cycle types? Kasi remember, ang dalawang elements are conjugates precisely when they are of the same cycle type, di ba? So, paano natin malalaman? So, when you look at S sub 3, ano yung mga possible, by the way, ano yung mga elements ng S sub 3? Ito yung mga pangalan, yung ID, row 1, row 2, mu1, mu2, mu3, pinangalanan ko yan. But technically, you don't have to give a name. You just have to know the cycle types. Halimbawa, yung ID, mag-isang type siya kasi lahat ito'y finifix niya. Walang conjugate sa ID maliban sa sarili niya. Okay? Yung row 1 tsaka row 2, they are 3 cycles. Si row 1 siya yung 1, 2, 3, 1 to 2, 2 to 3, 3 to 1. And then si row 2, siya yung 1 to 3, 3 to 2, 2 back to 1. In fact, wala nang ibang 3 cycles na pwede. Okay? And then the other types are the 2 cycles. The 2 cycles are 1, 2, 2 to 1, 1, 3, 3 to 1, and then 2, 3. Ayan na yung 6. Sabi ko nga sa inyo before, ang tawag ko dito row 1, row 2, mu1, mu2, mu3. But now, you realize na hindi naman talaga kailangang pangalanan kasi you can basically just list down using the cycle decomposition. So, ano yung mga conjugacy classes? There are 3. Ito yung isang class, ito yung another class, and this is the other class. Kasi magkakaparehas sila ng cycle type. Did you understand? Why? So, conjugacy classes. There are 3 classes. The first class is the one that contains identity. The second class, the one that contains the 2 cycles, the 3 cycles rather. And the last class, the one that contains the 2 cycles. So, yan yung mga conjugacy classes. And how many conjugacy classes are there in S sub 3? How many did we construct? There are technically 3. Okay? Now, if you may, tingnan nyo, yung conjugacy classes na ito yung mga 2 cycles, these are the elements of the type 2 plus 1. Bakit 2 plus 1? So there are 2 cycles, tas yung isang element na fixed. Do you get my notation? Notation lang naman ito. Yung class 2, how do I write this using this notation? This is the type 3 plus 1. Mali yata ako sa 2 plus 1. Tama. Hindi 3 plus 1, 3 lang. Kasi 3 nga lang pala talaga ang elements ng S sub 3. Sorry. Type 3, type 2 plus 1. And how about the identity? Yung identity, siya yung, dahil lahat ay na-fix, siya yung type na 1 plus 1 plus 1. Did you understand these notations that I use? I hope I can, kasi itong notation ko na ito, akin lang ito, na just to, this helps me understand the concept of conjugacy better. Yung notation ito. Kaya tinuturo ko sa inyo. Hindi ko alam kung ano yung tawag dito, but yeah. So the question now is, how many conjugacy classes are there in S sub 4? Do we have to list down all the elements? The truth is, you don't have to list down. Nagkataon lang na ang S sub 3 ay may 6 na elements lang, kaya nagawa natin i-list sa lahat. Pero kapag S sub 4, meron ka ng 24. You don't want to list them all those, no? So, ano yung mga conjugacy classes? How many are them? So, syempre, ang una sa lahat, huwag niyong kakalimutan yung identity ay mag-isa. Ito yung type 1 plus 1 plus 1 plus 1. This time, meron ka ng 4 na elements. Okay? Kaya 1 plus 1 plus 1 plus 1. Each one is being fixed by this permutation. At wala nang ibang nakakagawa nun maliban sa identity. And then, class 2, ano yung gusto nyong class 2? Well, pwede yung mga yung mga 2 cycles, no? Yung mga 2 cycles can be written as 2 plus 1 plus 1. Kasi yung dalawa lang gumagalaw, yung other 2 are fixed. Okay? Huwag na natin lagyan ng brace pala. Kasi nagmumukha siyang set. Set siya, pero hindi naman natin ma-enumerate lahat. So let's just use columns instead. Ito yung identity. Class 2, ito yung mga 2 cycles, A, B. Class 3, ito yung mga, you could have products of 2 cycles. Di ba? Products of 2 cycles. Kasi may 4 na elements sa SM4, na pinapermute ng mga permutation sa SM4. So, sabi nga ni Frank, ito yung 2 plus 2. Correct? 2 plus 2 type. You could also have, well, 3 cycles. Ito yung 3 plus 1 type, A, B, C. Kasi kapag may 3 cycle ka, isang element mo, automatic fixed na. Kaya ito yung type 3 plus 1. Okay? Meron pa ba iba? Yes, yung mga 4 cycles, A, B, C, D. These are of type 4. Wala nang iba. Diba? Parang annotation ko 4, ito yung 3 plus 1, 2 plus 2, 2 plus 1 plus 1, tsaka 1 plus 1 plus 1 plus 1. Can you think of any other conjugacy class? Wala na, no? Ito na lang yung lahat ng possibility. Do you agree with me? Okay. I hope you can see why these are the only conjugacy classes. So in SO4, how many classes are there? There are 5. Okay, because there are 5 cycle types. So the question is, how many conjugacy classes are there in S sub n? Kung titignan ninyo, it's like counting the number of ways we can partition n as a sum of positive integers. Halimbawa kasi yung 3 kanina, there are 3 different ways to partition 3 as a sum of positive integers. Una, yung 3 mismo itself, 3. Na ito yung una. Pwede ring 2 plus 1 or pwedeng 1 plus 1 plus 1. Kapag ang n mo naman ay 4, ano yung mga possible ways to partition 4 as a sum of positive integers? Siyempre yung trivial decomposition yung 4, na pwedeng 3 plus 1, hatiin mo sa 3 at 1, or pwede mo hatiin sa 2, 2, or pwedeng 2, 1, 1. Para kang may 4 na mangga. Parang in how many ways can you place these mangoes in baskets where these baskets are non-empty? Na kailangan may at least 1 element in each basket. Pero pwedeng isa lang yung basket mo, yun na yung as a whole. Pero pwedeng may 2 kang basket, yung isa may 3, isa lang. Pero pwedeng 2 basket, tig-2 sila. Or pwedeng 3 basket mo, 2 yung laman ng isa doon, tig-isa yung 2. Or pwedeng may 4 kang separate na baskets na may tigi-tig-isa. Do you understand? I hope you understand, ha? So if I have a 5, sige nga, let's count the number of conjugacy classes in S sub 5. Can you do that? Sige, sa S sub 5 tayo, S sub 5. What are the classes? Conjugacy classes. Sulat na lang natin yung notation natin. Siyempre yung plus 5, isang basket, 5 mangga. Okay? Kapag dalawang baskets, ano yung mga possibilities? Pag dalawang baskets, you could have 4 plus 1, you could have 3 plus 2. Ang 3 plus 2 parehas lang sa 2 plus 3 kasi ang disjoint cycles ay nagko-commute naman. So you don't have to count, 'di ba? You don't have to count you don't have to think about that. So wala na. 4 plus 1 tsaka 3 plus 2 lang. Kasi ang 2 plus 3 in terms of cycles, because they commute, disjoint cycles commute, parehas lang yung 2 plus 3 sa 3 plus 2. Okay. Ito na yung dalawang basket. Ito yung 1 basket. Ito yung gagamit ka ng 2 baskets. Dalawa. Kung gagamit ako ng 3 baskets, pwede ba? Yes, di ba? Okay, yes, very good. 2 plus 2 plus 1. Meron pa bang other ways to use 3 baskets? Ang 2 plus 1 plus 2 parehas lang yun. Wala na? Yes, very good. So I think gigets nyo na yun dyan. Yung 4, magkano ng 4 baskets? Well, you could have 2 plus 1 plus 1 plus 1. And I don't think there is any other. Yeah? At syempre, yung gagamit ng 5 baskets, ito na yung maximum. 1 plus 1 plus 1 plus 1. Kung ililista mo yung itsura ng mga permutations na nandyan sa bawat type, syempre yung 5 basket, ito yung mga 5 cycles. Okay? Yung 4 plus 1, ito yung mga 4 cycles. Yung 3 plus 2, ito yung product ng isang 3 cycle tsaka ng isang 2 cycle. Kasi that's possible in S of 5. In 2 plus 2 plus 1, ito yung product ng dalawang 2 cycles na disjoint. Ito naman mga 2 cycles lang. At syempre, identity. Mag-isa ulit siya sa kanyang class. Pag nilista mo lahat yan, 120 dapat lahat yan. Di ba? Kasi 5 factorial. So these are the only permutations in S of 5. 120 sila lahat. Classify natin. We were able to classify them in terms of conjugacy classes. So how many conjugacy classes did we make? We have 6 classes. So kung gagawa ka ng table, 3, 4, 5, sa S of 3 may 3 classes. Diba? Ang 4, S of 4, ilan ba? 5. We created 5. Sa S of 5, we were able to come up with 6 different classes. Yes, meron pa kang 3 plus 1 plus 1. 3 plus 1 plus 1? Oo nga, correct. Tama. Meron pa lang 3 plus 1 plus 1. Na-miss out ko yun. Sabi ni Stephen John, meron pa raw 3 plus 1 plus 1. Saan yung papasok? Dito sa 3 basket. No? So, tignan nyo. May nakaligtaan ako isa. Ang 3 plus 1 plus 1, ito yung mga 3 cycles. Did you understand? So, hindi pala 5. There are actually 2, 4, 7 pala. Hindi pala 6. There are actually 7. Meron pa ba kayo naisip na hindi ko nakikita? Thank you, Stephen, ha? Hindi ko napansin yun. So, nakita nyo, kahit si Sir, hindi ko alam yung formula. Ha? Diba? Napansin nyo? Hindi ko alam. Hindi ko sinadyang hindi ko alam, kunwari, na talagang hindi ko alam yung number. I am doing this manually. Kasi the truth is, I don't have to know because the truth is, there is no formula. There is no available formula. In general, there are P of n conjugacy classes in S of n where P of n is the number of ways to partition n into a sum of positive integers. Di ba? Alam natin yan yun. The question is, how many ways can we partition an integer into a sum of positive integers? Is there a way to count? Alam niyo, napakasimple ng problem na yan. No? Napakadaling intindihin, but yeah, this number theoretic problem is very hard to solve. Akala nyo trivial yung number, yung kung meron ba tayong formula to count the number, to count P of n. So for example, sabi ko nga, ang n natin when n is 3 ay, when n is 3, ano yung value ng n? It was 3 and then 3, 5, 7. 3, 5, 7, 4, 5. Paano ngayon kapag 6? Paano pag 7? Paano kapag n mo 100? Diba? How do we count the number of ways to partition an integer n into a sum of positive integers? It looks like an easy problem in counting. No, it looks like an easy counting problem, but the reality is until today, until this date, until the time, until this video is being recorded, mathematicians don't have any closed formula for P of n. Kaya siguro kung kayo makakaharap ng madaling formula for P of n, sisikat kayo. It's one of the, this is one of wala pang nag-exist na formula na meron sa mathematics. In fact, may tawag dyan sa P of n. We call it the partition function. Alam niyo naman ba siya tinawag na partition function, right? Kasi you are partitioning n into a sum of positive integers. That's why it's called partition function. The problem with the partition function, gaya na sabi ko, wala tayong known na closed formula. But there are attempts to estimate kung gaano kalaki yung P of n pag malaki na yung n. Pero yung eksaktong formula, wala. Ayan, yung sinasabi ko, there is no known closed formula for P of n. Well, at least as of this date, as of this time, yeah, as of the time that I'm talking right now, wala tayong closed formula. Maybe later magkaroon, but I don't know. Maybe it is not possible to construct one. No, you don't know. I don't know if it is possible to construct one or if it is proven. Kasi alam nyo sa math, merong mga problems na na-prove natin that the solution cannot be attained. May mga questions sa math na kaya nating i-prove na that these questions cannot be answered kasi yung axioms ng mathematics are not enough to give answer to certain questions. Hindi lahat nasasagot ng mathematics. Katigilan niyo yung mga memes sa Facebook na yung mga pa-good vibes na ano ba yun? Kung meron daw tinuturo ang mathematics, it's that any problem has a solution. Nakikita ko yun sa Facebook. The truth is, it's not true. Hindi lahat ng problem ay kayang sagutin ng mathematics. Not all mathematical questions can be answered. Kasi, in fact, by the Gödel's incompleteness theorem, may theorem tungkol doon. Hindi sa isang mathematical system, laging may nag-exist na question that where our parameters or the axioms are not enough to answer that question. No? Maraming ganyan sa math. And we don't know kung itong partition function is one of them, na yung mga problems na hindi natin, kapag sinabi natin hindi natin masosolve, it doesn't mean, pag sinabi ng isang mathematician na hindi niya masosolve yung problem, it doesn't mean na hindi niya talaga masolve. The truth is na prove niya that it cannot be solved within the parameters of mathematics. No? Do you get what I mean to say? Even the impossibility of something has to be proven in mathematics in order for you to declare that it is impossible to solve. I just don't know if this partition function is one of those problems in mathematics. Marami. As you move on to higher level mathematics, makikita nyo there are a lot of problems that cannot be solved actually. Sabi ko nga sa inyo, kung hindi naman natin malaman yung exact value or exact formula for P of n, there are, however, estimates on how to estimate the size of P of n whenever n is large. This one is due to Ramanujan originally, but it was Hardy who gave an explicit kasi si Ramanujan, isa sa mga lumang tao yan, napakagaling yan. He is considered genius. He is considered as the, sino ba siya? Kumbaga kung sa music parang mala Mozart ang level niya. No? Si Ramanujan is an Indian, he's an Indian mathematician. I don't know if he has a formal training in mathematics, but he has a lot of results in number theory that are still recognized up until today. But it was Hardy. Si Hardy ay isang modern na mathematician na who give an elaborate proof to this. Ang sinasabi, excuse me, sandali lang ka. Yung sinasabi ng formula na to, when n is large, yung P of n is asymptotically the same as 1 over 4n squared root of 3 e raised to pi times the square root of 2n over 3. So how do you make sense of this? Anong ibig sabihin yan? Ang meaning nito, kasi kayo mga college students, so naiintindihan nyo na dapat ito. Ang ibig sabihin nito, kung ano man yung formula sa P of n, we don't know, di ba? Sabi nga natin, wala tayong alam ng formula. Pag dinivide mo to sa 1 over 4n square root of 3 e raised to pi square root of 2n over 3, pag dinivide mo yun and take the limit as n approaches infinity, the limit is exactly 1. Yun yung ibig sabihin ng expression na yan. Hindi sabihin ng asymptotically the same or asymptotically equal. Kapag sinabing ganyan, kapag daw yung n is large, okay, yung ratio nung P of n tsaka nung estimate na yan is already very, very close to 1. Naintindihan nyo? This is already very close to 1. Yan yung ibig sabihin ng notation na yan, ha. If n is very far away from 1, yung P of n, yung ratio na ito is close to 1. Di ba kapag ang ratio ng dalawang number ay close to 1, ibig sabihin they are almost the same. Kasi kapag ang ratio equal sa 1, equal sila. Oh, do you understand this formula? Okay. So let's move on. May tanong pa tungkol sa partition function? Kaya wag niyo the truth is we can enumerate the conjugacy classes for a given value of n, s of n, pero wala tayong exact count na kung gaano kalaki yung P of n, yung number of conjugacy classes. We can count it for small values of n, but it's very hard to count it for an arbitrary large value of n. But we do have an estimation. Ito nga yung ating estimation. You can use this to approximate. Okay? Let's now talk about normal subgroups. Di ba ang mga groups, may mga subgroups. Some subgroups are called normal. Anong ibig sabihin ng normal? Let's recall, to understand normality, let's first recall the following fact. If you have a subgroup H of G, and you take an arbitrary element, little g of G, you know that the left coset GH is not necessarily the same as the right coset HG, because groups in general are not abelian, so the operation is not necessarily commutative. If you multiply to the left, it doesn't mean you will get the same if you multiply to the right. Diba? As an example, explicit example, bigay tayo ng group na D sub 8, dihedral group of the um, regular octagon. So, pag regular octagon, I don't know kung ilang degrees yan, basta think of it this way. May, paano ba octagon ganyan? Oh my gosh. Ito yung ano lang naman, di ba? Hindi naman siya kailangang perfect in lang. But I hope you understand, na? So kung tatawagin natin itong mirror na S, ito yung RS. Mali pa. Hindi to mama. Ito yung mirror ni RS. Ito yung mirror ni R squared S, R cubed S, R to the fourth S, R to the fifth S, R to the sixth S, R to the seventh S. Yung R, siya yung unit rotation. Yung unit rotation at the center at an angle of 360/8. No? Ano yung 360/8? Can you do 360/8? What's that? 45 degrees. Ang pinakamaliit na rotation ay 45, tapos 90, tapos 135, etc. Okay? So here, let's consider the subgroup H that is generated by R squared. So CH ay ID R squared. Pag in-square mo R squared, it will give you R to the fourth. And it will, if you take the cube of R squared, you get R to the 6. If you take the fourth power, you get R to the 8. So you're going back to the identity. So there are 4 elements in R squared. In fact, ito yung 0-degree rotation. Ito yung 90-degree rotation. Ito ay 108 degrees. At ito yung ano ba susunod? 270 degrees rotation. Alam niyo kung anong essence na itong H? Kasi ganito yan. If you look at this octagon, if you draw an octagon, I just cannot draw this perfectly. Pagpasensyahan niyo na. Yeah, if this is the octagon, you know, I can somehow draw, I can connect midpoints of this, and then using those midpoints, I can draw a square within, no? Yung 90 degrees, yung 0 degree, 90 degrees, 180 degrees, 270 degrees. As you notice, they are the rotations of a square, no? Rotation siya ng square, at the same time, rotation siya ng octagon. Ito yung 90 degrees, no? Yung R squared. Yung R, hindi siya symmetry ng square. Symmetry lang siya ng octagon. Pero yung R squared, R to the fourth, R to the sixth, parang imagine niyo kasi there is an embedded square there, no? Naintindihan niyo bakit naging subgroup ito? Yeah, do you get to understand why this formed a subgroup? Parang yung ano nito, yung anong tawag dito? Yung set na finifix nito ay isang square dun sa loob ng octagon, parang ganun. So now that because H has 4 elements, anong index ng H in D8? What's the formula for the index?
4.
4. Pero how did you get 4?
16 divided by 4.
16 divided by 4, correct. So that's 4. But 16 kasi T sub 8 has 16 elements, 8 rotations, 8 mirror reflections. So 16 divided by 4, that's 4. So what is this for? We are expecting
4 number of cosets.
yes, 4 left cosets and 4 left cosets. No? So first, let's begin with the left cosets. So what are the left cosets of H? Of course, H itself is a coset. Ito, siya kasi si EH. Identity H. Sorry. So si H lang yan. There's nothing really new about this coset. Mag-iisip ka ng element na wala sa H. Kasi pag ang multiply mo sa H, nasa H na, ang lalabas lang, H lang din. Diba? So think of an element na wala pa sa H. Halimbawa si R, wala sa H, di ba? So you just multiply R to H. You get R, R cubed, R to the 5th, R to the 7th. As you can see at this point, lumabas na yung 8 rotations. So kung gagawa ka ng another coset, you choose an element that's still not mentioned. Ano ba? S is not mentioned. You can do SH. If you multiply S on the left, you get SID is S. SR squared is, anong formula sa SR squared? Saan equal yung SR squared?
R6S.
Yes. Ang formula ulit, SRK is R to the 8 minus KS. O kung ayaw yung tandaan yung formula na yan, you could just do this using this equation repeatedly. Ang gagawin nyo SRR. Tapos yung SR, papalitan nyo ng R to the 7S. Tapos may R ka ulit. Pero ka ulit SR. Uulitin mo lang. Meron ka ng R to the 14. 14 modulo 8 is 6. Diba? Pero sabi ko nga sa inyo, para mas madali, tandaan nyo lagi yung formula na binigay ko. Shortcut yung binigay ko eh. R to the 8 minus K S. Kasi ang N natin this time is 8. Okay? Yeah? Understood? S. So ito yung R to the 6S. Eh yung SR to the 4th. Ano yung SR to the 4th? That's
R4S.
R4S. So nakita nyo yung R to the 4th nagko-commute with S, no? Kasi ang SR to the 4th is R to the 4th times S. Hindi kagaya ng R squared. Ang R squared hindi siya nagko-commute with S. Ang SR squared kasi is not R squared S. It's R to the 6S. Eh how about SR to the 6? Yun yung R squared S. Finish. Do we have other elements that are not yet here? Yes, we do have, no? Sino-sino pa? Si RS wala pa. So you might as well put an RS here. RS. So in short, lahat ito, multiply mo lang ng R sa kaliwa. Kasi ito na yung SH eh, di ba? So if you want an RSH, you just multiply each one of this by R. Ang lalabas RS, R to the 7S, R to the 5th S, R cubed S, and you're done. Makikita nyo, yan yung 16 na elements nung D sub 8. And they are partitioned into left cosets. Each one has 4 elements. Alright, so let's do the right cosets this time. Ang una sa lahat, HID, hindi yan nawawala. So this is basically H. And quite expected na ang HID pare sa IDH kasi identity yan eh. It commutes with everybody. It's so good that it commutes with everybody all the time. Di ba? How about HR? If you do HR, sa kanan tayo mag-multiply. As you can see, it doesn't matter as well. Kasi mga powers ng R ang ano involved. So if you multiply by R, whether to the left or to the right, it won't actually matter. And if you multiply by S on the right, anong lalabas? Meron kayo mapapansin. Ay, saan ako nag-multiply? Sorry. HS. Ito yung H pala. Multiply ka ng S. S, R squared S, R to the fourth S, R to the 6S. And if you multiply an RS to the right, you get to the right tayo mag-multiply na RS. So magiging R squared, RS R cubed S, R to the 5th S, and R to the 7S. Do you notice something?
Equal lang po yung left coset at right cosets.
Yeah, precisely. In fact, that's what I would like to point out. The truth is what happened in this example was that remember in general, the manner how the left cosets will partition the group will generally be not the same as the way the right cosets will partition the same group. Diba? Posibleng, remember when we're talking about cosets before, there may be, the right cosets might partition the same group in a different way than the left cosets do. No? But in this example, as you can see, this choice of H is quite unexpected because with this choice of a subgroup, whether you look at the left cosets or you look at the right cosets, they actually partition the group the same way. Parehas. Roughly, or in abstract algebra, we say that the left cosets and the right cosets coincide. They are precisely the same. And yeah, this in abstract algebra, this is a thing to celebrate. Kasi nga, in group theory, this is a thing to celebrate. Kasi ang groups are not necessarily abelian. The operations are not necessarily commutative. That's why when the left cosets and the right cosets of a subgroup coincides, no, that's something to celebrate. That's a special occasion. That's why we give a name to this type of subgroup. In group theory, we say that a subgroup N is normal, no, if the left cosets coincide with the right cosets. In other words, for all G, little g, in capital G, the left coset Gn simply equals the right coset Ng, just like in the previous example. And if N is a normal subgroup, we have a special notation for it. Diba? Normally, we write N subgroup of G kapag plain na subgroup, no? But to indicate that it is not just a subgroup, it's a subgroup to be celebrated because it's normal. Yeah, nilalagyan natin ng ganun. To indicate that the subgroup is not just a particular subgroup. In general, nakahanap ka ng interesting one because its left cosets and right cosets coincide. Now, what's nice when a group is normal? Ayan. Unang-una sa lahat, parehas ngayon, you do not have to distinguish between left cosets and right cosets. You can just say the cosets of N. Regardless of whether it's right or left, it will not matter in general. So, naintindihan niyo yung definition natin ng normal? Yeah, kaya nga ako lagi nag-start with an example, especially when the definition is quite challenging. Kasi alam niyo, pag binasa niyo yung definitions na to, ito yung mga students, little dito, normally. When students saw this definition, they normally think that the group is abelian automatically kasi ang Gn ay nag-i-equal sa Ng, no? They think na nagko-commute yung G with every element of N, but that is not really the case. When you look at the previous slide, nasan ba yun? Tignan nyo ho, yung tingnan nyo, yung SR is not the same as RS. Pero ang SH parehas sa HS. Kasi the truth is, yung S, pag minultiply ko siya sa R squared, for example, when I multiply R squared pala tayo. Tingnan natin yung S squared, tsaka yung SR squared, tsaka yung R squared S. Yung S, upon multiplying it to R squared, naging R to the 6S. Yung S, pag minultiply ko sa kanan ng R squared S. So technically, hindi ito parehas. Nagkataon kasi na yung SR squared, hindi man siya R to the 6S, it is the other element. It is, sorry, ano sinasabi ko? Yung SR squared, hindi man siya R squared S, it is R to the 6S. It's still in the same coset. Nagkataon yun. Again, hindi ibig sabihin nito that S commutes. Oh, warning yan ha. Warning. Lagay ko dito, warning. The equation or the equality Gn equals Ng does not mean that G commutes with the elements of N. Hindi yun ang ibig sabihin yan. Ang ibig sabihin ng Gn equals Ng, yung set na Gn, remember Gn is a set. The set Gn is exactly the same as the set Ng. Pero it doesn't imply na si G ay nagko-commute with every element of N. Sabihin lang nun, pag kumuha ng isang element ng N, let's say little n, yung Gn, hindi man siya parehas sa Ng, it is something else na nandoon sa Ng. Did you understand? Maintindihan nyo? Halimbawa, kumuha ko ng N. Kumuha ko ng N. No? Yung Gn equals Ng does not imply na ang Gn ay parehas sa Ng. Eh anong sinasabi ng Gn equals Ng? However, so this is what it means. Yung Gn equals Ng implies what? Yung Gn mo can be written in the form N1G for some other element N1 in N. Yung N1 need not be equal to N. Did you understand? Kaya ako nilagyan ng subscript na 1. Kasi it may be something else from capital N. Did you understand? N1 is not necessarily N. It could be some other element in N. Nililinaw ko lang. Kasi this is a common error to students. Kapag sinulat nila N is a normal subgroup of G, iniisip nila na kapag kumuha ka ng element ng G at kumuha ka ng element ng N, they tend to think na ang AN parehas sa NA. This is very wrong. No? That's wrong. Huwag niyong gagawin yun. That's wrong. Okay? Ang ibig sabihin ng GAN is equal to NA, where N is the set, yung A times little n mo, it may be something else from N times A. Naintindihan ba? Okay. I hope you get that warning. But of course, hindi naman natin pinagbabawalan na maging abelian si G. And so kapag abelian si G, walang usapan. Every subgroup will be normal. Nangyayari yung gusto nyo mangyari yun, Gn pares talaga sa Ng element-wise. Hindi siya set-wise, element-wise. As in, nagko-commute yung mga elements because abelian nga yung group eh. Kaya lahat ng subgroup mo normal. Eh when we talk about normal subgroups, we don't use abelian groups as examples, really. Kasi automatic, kapag abelian yung group, lahat ng subgroups mo ay normal. Right? Lahat ng group may automatic na normal subgroups. Ano yung dalawang automatic na normal subgroups? The group itself, yeah, Kasi kapag ang n mo ay si G, ang index mo ay 1. Kaya ang coset mo, isa lang. Si G lang din mismo. Di ba? Kaya lahat ng left cosets mo, trivially, pareha sa right cosets mo, si G lang, wala nang iba. On the extreme end, when you now look at the trivial subgroup, ano yung mga cosets ng trivial na subgroup na E? Ang mga cosets nito yung mga tigi-tigisa. No? Yeah. Bakit normal yan? Kasi ang GE, ang laman nito isa lang eh. GE, which is G. Diba? Eh ang G, pwede mo rin naman isulat as EG. So you could write as EG. So technically, kahit na ano yung G, diba? Yung G na yung pag minultiply mo sa subgroup na yan, whether from the left or from the right, pares lang kasi nga si E nagko-commute with everyone. It's the class president. It's friends to everyone. O totoo ba? Naintindihan yung remarks na ito? Ito yung mga trivial examples. So normally, interested tayo sa mga examples na number 1, non-abelian group. Pangalawa, yung mga subgroups na maliit sa G, pero mas malaki sa trivial subgroup. Normally, doon tayo mag-work kasi these are the unexplored ones. Halimbawa, meron tayong example kanina. So subgroup na D sub 8, yung subgroup generated by R squared is a normal one, as you have already seen. Yeah? Ganun talaga, iisa-isahin niyo yung mga left cosets and find that the right cosets coincide. On the other hand, if you now look at the subgroup K generated by the reflection S, so dahil si S is a reflection, dalawa lang ang elements ng K, si ID tsaka si S. Yeah? So, we want to show that K is not normal. So, how do you do this? You don't have to check this one by one. Mag-check lang kayo one by one kapag nagpo-prove kayo ng normality. Kapag ang ipo-prove nyo not normal, you just have to find a counter example. Sabihin, you just need to get an element which when multiplied to the left and to the right of K yields two different things. Halimbawa, consider the element R. Okay? If I multiply R on the right, I get, of course, R SR. Right? But SR in D sub 8 is R to the 7 S. On the other hand, RK is RS. And these two sets are not the same. So therefore, ang RK hindi pareha sa KR. This one counter example already is a proof that K is not normal. You don't have to do it one by one. Do you understand? Okay. Okay. In S sub 3 now, let's look at the subgroup H generated by the 2-cycle 1, 2. It's a 2-cycle, so it's order 2. It will generate 2 elements only, identity and itself. If you multiply a 2, 3 on the left of H, you get, how did I get 1, 3, 2? Ang idea dyan si 2, 3, pag multiply sa 1, 2 kasi, titignan mo, saan magpupunta yung 1? Check mo dito, si 1 pupunta sa 2, si 2 pupunta sa 3, kaya si 1 pupunta sa 3. Saan pupunta si 3? Si 3 here is fixed, but 3 here will go to 2. So pupunta si 3 sa 2. Saan pupunta si 2? 2 will go to 1, and 1 here is fixed. So si 2 babalik na sa 1. Okay? So nakuha nyo na bakit yan ay ganon? 1, 3, 2. Nasundan nyo yun ha? Okay, sige. But when you look at H23, paano yung H23? Yung 2, 3 mo multiply mo sa kanan. So 2, 3 yung una. Sige, gawin natin yung 1, 2, 2, 3. Check nyo muna saan nagpupunta si 1. 1 is fixed here, but 1 will go to 2, so 2. How about 2? 2 will go to 3. 3 is fixed here, so 3. Now 3, where it go? Of course, automatic sa 1 kasi nasa S of 3 tayo, wala na siyang ibang pupuntahan. So ito ay 2, 3, 1, 2, 3. And these two elements are not the same. Kasi ito si 1 pupunta sa 3. Dito si 1 pupunta sa 2, di ba? Hindi parehas na function yan. Kaya, itong dalawang cosets na to are not the same. So that is enough to prove that H is not normal. Alright, by the way, when you say that H is not normal, you always have to mention where. Now, sometimes kasi, when you look at the subgroup, it may not be normal with respect to the group itself, but it is normal in a larger subgroup. What do I mean by that? Ito si group. Ito yung H na tinitignan natin, for example. Maaari kasi, it is sometimes possible that H is not normal in G, no? Pero when you look at a larger subgroup than H, let's say this is the subgroup K, sometimes si H ay hindi normal sa G, pero si H ay normal sa K. No? There are instances where this thing can happen. Kaya kapag sinabi niyong H is not normal, hindi siya kompleto unless maliwanag siya from the context. So, in order for you to be safe, you say where it is not normal or you say where it is normal. Do you understand what I mean to say? Sige. So, I have some few remarks. Number 1. If N is a subgroup of G and G, N has index 2 in G. Anong sabi ng N has index 2? Anong ibig sabihin ng N has index 2? How do you think about N? Sige, bigyan nyo ng interpretation yung N has index 2 in G. Sabi sa inyo, when you read a theorem, or when you read a result, a remark, or whatever, you don't read it as it is. Sometimes you have to think about the statement and let the message come across. No, ibig sabihin, you don't just read it as a sentence. Tingnan nyo kung ano ba talaga yung essence niya, ano yung sinasabi niya. Sige, kagaya nitong remark nito, what does that say? Kapag ang index ay 2, so ano yung sabihin ng index ay 2? Yan, sabi ni Aaron, kalahati si N ng G. Very good. In fact, yun yung gustong sabihin yan. Kapag yung subgroup mo, ang size ay kalahati ng group, automatic normal siya. Why would that be? In fact, you can prove this. You can argue this. Kaya yung gawin ito yung proof nito. Bakit? Tingnan natin ha. If this is 2, sabihin yan, N has 2 left cosets or right cosets. It doesn't matter. Pares lang naman yan. Okay? Ano yung dalawang cosets na to? namely N and Gn, where si G ay kuha ka ng element G na wala sa N. Dalawa lang naman yung coset niya, di ba? Parang ito si G, kalahati niya si N, the other is Gn. Kumuha ka lang ng kahit sinong G na wala sa N. Kasi kapag ginawa mo yung G sa N, automatic ang Gn ay N lang, di ba? Okay. Why is this normal automatically? Kasi tingnan nyo, kapag ang A kasi, sige ganito, let A be in G. Kapag ang A ay kinuha mo sa N, case 1, automatic ang AN mo N lang. Kaya parehas yan sa NA. It doesn't matter. Kapag ang A naman ay wala sa N, gaya ng sabi ko, ang AN ay hindi parehas sa N. So, ang AN also, mali ako. Also, ang NA hindi parehas sa N. Diba? If N union AN is G, N union NA is G, tapos disjoint sila, ano sinasabi niyan? Kumbaga ito yung group mo, ito yung N, yung other part AN. Nasaan yung NA? Yung NA couldn't be N. Si NA ngayon, sino si NA? Si NA, it couldn't be N kasi nga yung A wala sa N, di ba? So, sino siya? Dapat yung other part. Yung NA mo, napipilitan, mapapwersang yung AN mag-equal sa NA, yung other half. Kaya in either case, ang AN parehas sa NA. Kaya, anong klaseng subgroup si N? N is automatically normal. Katandaan yan ha? Kapag ang index ng subgroup ay 2, automatic normal siya. Kapag kalahati siya ng group. At sino yung example na naiisip nyo? Dapat may isip nyo kagad yung example na yun. Kasi meron tayong example ng group, subgroup na kalahati mismo exactly ng given na group. Sige nga. Sino pumapasok sa isip nyo when you think of a subgroup that has an index 2? Sige, pagalingan tayo ng memory. Sinong subgroup yun? At sino yung group? Sino yung subgroup ng index ay 2? Yung sikat na sikat. Ha? Hindi nyo maisip kung sino? A4 sa S4. Correct. Kalahati yun. In general, AN. Di ba? Kahit na ano yung AN, yung mga even permutations, do you remember them? They form a subgroup which is exactly half of the group S sub N. In general, ang A sub N is a normal subgroup of S sub N. Okay? Pero yung kaninang example ko, yung ano, saan ba yun? Let me go back to that example. Ito, si H ay normal, pero ang index ng H ay hindi, 2. It's 4 actually. Ito naman 1/4 or 25% ng group ang size niya. 1/4, yun yung sabihin ng 4 na index. 1/4 lang siya ng buong group. So, hindi porket hindi na 2 ang index, hindi na normal ha, hindi ganun yun. Kaya pwedeng ang index mo is something else, but still, it is normal. But in general, if the index is 2, it's normal. Kasi ang reason, si A sub N ay kalahati talaga ng S sub N. Okay, so in this example, mag-i-introduce ako ng panibagong group kasi you haven't seen this group yet. This group is denoted by Q sub 8. And it is the group of units in the field of quaternions or whatever. Kung ano man yung in the ring of quaternions. Sorry, hindi siya field. Ano ba yung mga quaternions? Let me just explain the quaternions in full. Yung parang ano lang, introduction lang. Naalala nyo when you started learning complex numbers? Ano sabi ng teacher ninyo? So you got a real number A. Ang gagawin natin to form a complex number, you just add another part of it. You call it BI. B is the imaginary part. I is an element whose square is -1. I can't be real kasi walang real number na ang square ay -1. So we are introducing this para magkaroon tayo ng mga roots sa mga quadratic equations, di ba? Kaya natin yan in-introduce. Ang history nito in algebra to get solutions to every kind of quadratic equation. Lahat ngayon masosolve na kapag lahat ng quadratic ngayon masosolve mo na kapag may mga complex numbers ka na around, di ba? Yun yung benefit by introducing a complex number. Pag sinabing, so this is a complex number. So you needed how many real numbers to describe a complex numbers? You needed to in order to define a complex number. So, parang sinasabi natin yung set of complex numbers is, sa linear algebra, mapapag-aralan nyo to. C is 2-dimensional over R. Yan ang sabihin natin ng dimension. Sabihin ng C is 2-dimensional over R. You actually needed a minimum of 2 real numbers in order to describe all the complex numbers. Yung sabihin ng dimension. Kapag sinabing quaternions, meron tayo sa math na tinatawag ng mga quaternions. Ang quaternions, extended complex number siya. Para kang meron ka ngayon dalawang complex number, gagawa ka ng another imaginary unit na J, iba siya sa I, pero still ang I squared at J squared gusto natin ay -1. Mga imaginary units, okay? And pag sinimplify mo to magiging A plus BI plus CJ plus DIJ. Nagkaroon ka ngayon ng DIJ. Tapos yung IJ na ito, dinidefine natin siya as some other constant, as some other symbol K. So technically, erasing all of this, a quaternion is just a 4-dimensional, sabi natin complex, parang complex number pero 4-dimensional. Meron BI, CJ, DK, yeah? Anong property nung I and J at K? Pare-pareha silang imaginaries. So, sabihin ang squares nila ay -1. No? In fact, ang product nilang tatlo ay -1 din. Okay, those are the quaternions. Now, ang ginagawa natin to form a group, kinukuha lang natin yung mga basis elements na tinatawag. Sa linear algebra ito, but ang sabi lang naman ng basis elements, yung mga elements na kailangan mo to generate all the quaternions, which are 1, I, J, and K. Kasi si A, B, C, D can be arbitrary real numbers. Tapos, sinasama natin yung mga negatives nila. So, 8 yan lahat. Ay, sorry, may mali si sir. Yung 1 may plus minus 1 din. Okay? I forgot to put that plus minus sign before -1. So si Q8, 8, 1, -1, I, negative I, J minus J, K minus K. Now, if this is a group, what is the rule? The rule is Eto, I squared, J squared, K squared is -1, and -1 is IJK. In other words, you can say that Q8 is generated by the elements IJK, where this is the rule. This is the rule of the game. Yeah. So that's the presentation, the group presentation. It can be generated by 3 elements. Na ang squares ay -1. 1 is the identity, being the identity. Tapos yung IJK, yung product nilang tatlo ay -1 as well. Okay? So, isipin nyo ngayon, paano ka gagawa ngayon ng table? Paano ka gagawa ng multiplication? Halimbawa, paano ko i-multiply si I tsaka si J? How do I do that? To multiply I times J, titignan mo yung equation na ito. Equal kasi sila lahat, di ba? Ay, hindi. Ang titignan pala natin ay, hindi pala. Ito palang equation na to. Tsaka to. Since ang K squared is IJK, we are working in a group. So, right cancellation law holds. Diba? Cancel, cancel. Ano mapapala nyo? Aha, ang IJ ay equal sa K. Halimbawa naman, meron akong JK, sir. Saan ko kukunin yung JK? Titignan mo naman yung equation na to. Okay? Ang I squared daw ay IJK. So, cancelin mo yung I sa kaliwa, LCL. Hindi, sulat muna natin ng mahaba. IJK. So, ito yung left cancellation law. Cancel, cancel. Ang JK ay I. Okay? Paano naman, sir, yung KI? How do I get KI? I don't know. Paano gagawin yung KI? Based on this equation. Ang titignan naman natin ay saan ba tayo mag-start? So, IJK is -1, di ba? Pag nag-multiply ako ng I sa kanan, kasi gusto kong minus I. Kasi remember, gusto natin ito. So, how do we, get KI? Ang KI ngayon ay IJ inverse times minus I. Ano yung rules ng group? Ganyan. Plus minus I. Diba? Ang J inverse, kasi ang J squared ay -1. Sabihin yan, ang J times minus J ay 1. Kaya ang J inverse mo minus J, ito, minus I. Ganun din, pares lang din sa I, minus I. Ano mangyayari? Ang hirap ng algebra. Minus I times minus I is I squared. But I squared is -1. Kaya ito ay J. Kaya ang KI mo equal sa J. So to remember the formula, parang ito yung I, ito yung J, ito yung K. Lagyan mo ng arrow. Ang isipin ng arrow na yan, yung I times J ay K, yung J times K ay I, yung K times I ay J. So did you get the algebra needed to paano ko na-derive lahat ito gamit itong rule na ito? Naintindihan niyo yung notation na ito? Okay, I hope that you do. Let me erase this. Tignan naman natin, sir, yung JI. Ano yung JI, sir? Ano nga ba? Ganito. Ang ij kasi ay k. Remember, you wanted ji, no? At yung gagawin muna natin, alam ko na. If you wanted ji, you can use this second equation. Multiply ka ng j sa kaliwa, you get ji on the right. But remember, j squared is -1, so that is minus k. So ang ij ay k, pero ang ji ay minus k. So it indicates that this group is not commutative. Diba? Eh sir, ano naman yung kj? Ano yung kinumpit ko? Ang kinumpit ko ay ji. Ba't ko kinumpit yung ji? Kasi I wanted to know ano mangyari pag bumalik ako. Pag bumalik ako, magkakaroon ka ng negative sign. Okay? How about kj? Ang gagamitin mo naman yung first equation. Mag-multiply ka naman ng j on the right, maging ij squared equals kj. Ang j squared ay -1, so that's minus i. Ang kj ay minus i. So parang pag ganito yung arrow natin. Kj ay minus i, pero pag inaway mo yung arrow na clockwise, magne-negative. In fact, you can use the third equation to prove that ik is minus j. Yun yung rule of the game. Maintindihan nyo? Sige, tignan nyo kung paano magiging ganon. Sir, paano kapag minus ij? Ang minus ij, may formula ka na sa ij eh. Ang ij ay k, kaya minus k ang sagot. Remember, 8 ang elements natin, plus minus 1, plus minus i, plus minus j, and plus minus k. Kaya ang minus ij ay minus k. Kaya nga ang tatandaan nyo lang, kapag kayo nasa quaternion, pag kayo nasa quaternion group, you only have to remember this circle because this circle does wander. Kaya nyo nang i-multiply lahat kapag alam mo yung bilog na yan. Do you agree? Pag you go with the flow, the clockwise direction, walang sign. Pero kapag inaway mo yung kapag nag-counterclockwise ka, inaway mo yung orasan, you introduce a negative sign. Tingnan nyo, ij is k, jk is i, ki is j, pero pag pabalik ka, kj, negative i yun. Ji minus k yun. Ang ik minus j yun. So that's the rule. In fact, ito lang yung kailangan yung tandaan and which can be derived from this group presentation. Okay? So, you know, what's the next question? Ang next question is, what are the subgroups of this Q sub 8? At ba't naligaw itong group na to sa lesson na ito? Why is it nice to study here? The truth is, yeah. So what are the subgroups? Sabi nga natin, may dalawang uri ng subgroups. Yung mga cyclic subgroups, tsaka yung mga non-cyclic ones. Ang madali, mga cyclic, kaya unahin natin yun. Siyempre, the one generated by 1, the identity is singleton 1. The one generated by -1 is, ang -1 squared ay 1. Kaya dalawa lang, order 2C, diba? Ano mo ma-generate ni I? 1, I. Ang square ni I ay -1. Ang cube ni I, ang I squared -1. So, ang I cube minus I. Kaya ano naman yung I to the 4th? I squared yan. O di -1, -1, +1. So, babalik ka na sa identity. In short, order 4 yung I. In fact, ang I inverse ay minus I. Saan ko nakuha to? Kasi nga ang I squared ay negative 1. Kung ang I squared ay negative 1, ibig sabihin ng I times minus I is positive 1. Kaya ang inverse ng I ay minus I. Kaya yun din yung mag-generate ng minus I. You don't have to worry about that element. Dahil similar lang naman yung characteristic ni J kay I, ganyan din si J. Ang mag-generate ni J ay 1, J, minus 1, minus J. Tapos, minus J. Ang inverse niya, multiplicative inverse niya. Itong mga quaternions na ito, yung mga IJK, yung mga imaginary units na ito, sila yung mga algebraic elements na ang multiplicative inverse ay parehas sa additive inverse. Weird, no? Ang additive inverse, ang multiplicative inverse nila, parehas sa additive inverse. Hindi yan nangyayari for real numbers. Mangyayari lang yan kapag complex number. Pag imaginary, I mean. Kasi imaginary does not mean complex. Kasi si J is imaginary but it's not a complex number. Yeah. Right? Nakuha niyo yung mga cyclic subgroups? Ito na lahat, di ba? Meron kang cyclic subgroup of order 1, order 2, and order 4. Tatlong order 4. Anong ibig sabihin ng 0000, Brandon? Oh, napindot lang yung 0000. Okay. Napindot lang yung 0000. So, wala nang ibang subgroup. So, nakita nyo, first of all, na-observe pala natin, this is non-abelian, no? Kasi pag inaway mo nga yung bilog, nagna-negative. Kaya, non-abelian. So, it cannot be cyclic, kaya hindi mo ina-expect na magkakaroon ka ng generator for Q sub 8. That's not expected. So, yung mga non-cyclic subgroups, ito yung kailangan mo ng more than one element to generate. Siyempre, ang una sa listahan, Q8 mismo. Okay? Q8 mismo. Now, aside from Q8, are there any others? Try natin. 1. Nilagay ko si I. Alam nyo, ganito yan eh. The truth is, dahil kapag si I, J, at si K, pare-parehas order 4. Pag nilagay ko yung I, J, at K, makakaapat ka agad. Di ba ang subgroups according to Lagrange, kailangan ang order, divisor ng order ng group. So, aside from the subgroup of order 4, wala nang subgroup ng order ay 5, 6, or 7. There cannot be such subgroups. So, hindi ako pwedeng maglagay dito ng I kasi ang lalabas lang ito. Di ba? At hindi siya non-cyclic. Kailangan natin ay non-cyclic. Pag naglagay ako ng J, lalabas to. Pag naglagay ako ng K, lalabas to ng buong buo. So, I cannot put an I, a J, or a K. Ano na lang ang pwede? 1 or negative 1 na lang. Wala nang iba. Kaya lang, itong 1 at negative 1, ito na yun. Cyclic din yan. So, therefore, as you can see, from the Lagrange theorem, wala nang ibang subgroup. Aside from Q8 itself. Kaya ilang subgroups meron ng Q8? Ito lang lahat. Wala nang iba. Okay? Wala nang iba. So, we can now draw the lattice diagram for the subgroups. Q sub 8 ito. Meron siyang tatlong anak na cyclic of order 4. The one generated by I, the one generated by J, the one generated by K. May isang order 2, the one generated by negative 1, and one of order 1. So, ganyan yung itsura ng kanyang lattice diagram. Yung 1, -1 nasa loob ng tatlo na order 4, right? Naintindihan nyo? Okay. Now, what's nice about this example? Let me use another slide. Okay, what's nice about this example is that Q8 is non-abelian, yet all of its subgroup are normal. Galing, no? Bakit? Hindi, di ba? Kasi normal sa isang abelian group to have normal subgroups. All, walang exception. Pero for a non-abelian one, it's not quite normal to have all of your subgroups as normal subgroups. That's something to celebrate again, di ba? Bakit? Tingnan natin. Siyempre, ito normal, check, check by default. Itong tatlong ito, they are of index 2. So normal. Check, check, check. So it's short. We only have to check the cosets of the subgroup generated by 1. Diba? -1 rather. By the way. Since these are of index 2, then they are normal. And trivially, Q8 and this one is normal. So we only have to check the normality of the subgroup generated by -1, which is this. Kaya lang 1 and -1 yan di ba? If you take any Q, take any element Q in Q8, kahit na sino, ang Q times -1, it's just Q times -1 and minus Q, right? But you can actually do that on the right as well. Pares lang yan sa -1 times Q. Kasi 1 and -1 yan di ba? Do you agree with me? Therefore, this one is actually normal again. Therefore, the claim that all of its subgroups are normal subgroups is clear. Although it is not abelian, pero lahat ng kanyang subgroup ay normal. Naintindihan niyo ba? Why did I give this example? Kasi it tells us a lesson. Remember, tatandaan nyo, kapag si Sir ay nagbibigay ng example, I do not just give an examples. Normally, examples are there to tell you lessons. May mga may mga takeaway tayo palagi sa mga examples na binibigay. Hindi ako nagbibigay nung random na example lang na walang connect or walang something. Tandaan nyo, hindi kapag si Sir nagbigay ng example, pinag-isipan ko yung example na yun. I don't just give it nang wala lang. Normally, may mensahe akong gustong iparating. Now, this is the so-called normality test. Hindi ito yung normality test sa statistics. Kasi statistics merong normality test na tinatawag. It tests whether you can use parametric statistics or not. Or in other words, whether your data follows the normal distribution or not. So kapag ang data approximately normal, so sa statistics, diba, you can use the parametric statistics, yung mga t-test, yung mga ganon. But if, yeah, hindi na tayo mag-statistics. Punta tayo sa normality test sa group theory. The normality test simply tests whether a given subgroup is normal or not. Ang sinasabi nito, the following are equivalent statements, meaning if one is true, the others are also true. If one of these statements is false, ibig sabihin the others are also false. Kung mapapansin nyo, yeah, each one of these, ito, ang definition natin kasi nito, ito yung definition. By definition, for all G, ang Gn pareha sa Ng. Right? Right. Di ba? Yan yung definition. Yung number 2, number 3, number 4 ay iba dun sa definition. Ibig sabihin, kung equivalent sila sa statement 1, you can use them instead of the definition. In fact, ang totoong normality test dito yung number 4. Ito talaga yung ginagamit in order to show that N is a normal subgroup of G. But yung 2 and 3 are restatements of number 4. Now, let me explain them one by one now, before I proceed with the proof. Ang ibig sabihin natin ng G and G inverse, for your information, double coset ito eh. Pag sinabing double coset, nag-multiply ka sa kaliwa at the same time nag-multiply ka sa kanan. Ang laman nito are basically the conjugates of the elements of N by the element G. Kino-conjugate mo lahat ng elements ng N by the element G. Lahat minomultiply mo sa kaliwa by G, lahat minomultiply sa kanan. Dahil nga normal lang subgroup, saan equal yung mga conjugates ng N? Dapat equal yun sa mga elements lang din na nasa N. Kasi nga ang Gn ay equal sa Ng pag nag-multiply ka ng G inverse sa kaliwa. So obviously, itong dalawa ay equivalent talaga, di ba? Do you agree? Do you agree? Okay. So ganito. Sulat ko ha. 1 and 2 are clearly equivalent. This is trivial. When I say trivial, hindi naman sa automatic, pero it can be checked easily right away. Na? You just multiply a G inverse on the right, you get the equation. Okay? Yun 2, it implies 3 kasi ano, kapag si A ay subset, kapag si A ay equal sa B, nagpo-follow na si A ay subset ng B, di ba? Pero ang tanong, bakit si 3 equivalent kay 2? Bakit ini-imply ni 3 si 2? Ito rin trivial ito by definition. Pero bakit si 3 nai-imply si 2? Kasi this is amazing. Why? Kasi in general, kapag si A ay subset ni B, it doesn't mean that A is equal to B, right? Pero in terms of conjugation, kapag ito raw set na ito, pag yung mga conjugates ng mga nasa N ay nasa loob ng N, automatic, anong automatic? Anong automatic? Actually, lahat ng N kasama doon. Did you understand? Parang ganun yung idea nito. So, ganito yan eh. Assume number 3. For all G in G, we have G and G inverse a subset of N. We will prove that, ano kailangan natin ipakita dito? We need to show that N is a subset of G and G inverse. Diba? So take any element of capital N. Let's say N. And let G be in G. Kailangan ma-prove natin ito, no? So how do we show that? This is how we do it. Since G is a group, G is in capital G, yung G inverse nandun din sa G. By hypothesis, kahit na sino yung G dito, totoo yan. So in short, kahit palitan ko pa si G ng G inverse, totoo pa rin yan. Right? So, by hypothesis, G inverse and G inverse inverse is still a subset of N. Right? Or you can say G inverse and G is a subset of N. Consequently, pag yung little n na ito kanina, pag yung little n na ito, ay minultiply ko daw sa kaliwa by G inverse, sa kanan by G, nasaan daw ito? Nasa N pa rin. So in short, again, it doesn't mean na equal yan sa little n. Ang ibig sabihin niyan, si G inverse NG ay equal sa N1 for some N1 in capital N. Tinulang pa tayo ng space. So let me add another page. Then clear this thing out. There. Nandito na tayo, no? Ano yun? Si G inverse NG ay equal sa N1 where N1 is in capital N. So from here, we can solve for N. Mag-multiply ako ng G sa kaliwa, G inverse sa kanan, magiging ganito yan. Ang tanong, nasan tong element na to? Eh di nandito siya sa G and G inverse. So napatunayan ko na si N ay nasa G and G inverse whenever it is in N. Dito tayo nag-start. Si little n ay nasa capital N, na prove natin na si N ay nandito sa set na ito. So what does that show? It shows that N is a subset of G and G inverse as well. So kung ito ay totoo na, totoo rin ito, nagka-follow na ang G and G inverse ay equal sa N. And that is statement number 2. Kaya ngayon, equivalent yung 1 and 2, equivalent na yung 2 and 3. And actually, yung number 4 is just a restatement of number 3. Kung titignan niyo mabuti yung number 4, sinasabi lang niya kung ano sinasabi ng number 3. Kapag kumuha ka ng maliit na n sa capital N, kumuha ka ng maliit na G sa capital G, yung G and G inverse, nasa loob lang yun ng N. Naintindihan nyo? So 3 is trivially the same as 4 again. So ang prove lang natin dito bakit nababalik yung 3 pabalik sa 2, no? Yan lang tayo naglaan ng panahon. So, and we are now done. Kaya sabi ko sa inyo, ang statement 4 talaga yung essential dito. Siya yung tinatawag talaga nating normality test. Okay? How do we do the normality test? To perform the normality test, what? Ito yung G, ito yung N. To perform the normality test, ito yung proof template. Ito yung template. You start with let N be in N and let G be in G. Okay? Ang kailangan mo mapakita sa dulong-dulo, you just show that G and G inverse upon computation, you just need to show that it is in N. Pag kumuha ka ng N dito, kumuha ka ng G anywhere, kailangan yung G and G inverse, yung conjugate by G, mapatunayan mong nandito sa N. And once na-prove mo yun, tapos na. That already proves that N is normal. Nagets nyo? Naintindihan ninyo? Okay. So let's try to apply it this time to this example. Naalala niyo yung subgroup ng A4 na ito? Ito yung mga products ng disjoint two cycles kasama yung identity. Okay? 12 yung elements ng A4, 8 3 cycles, 3 products of disjoint two cycles, at identity. Kaya nga nang sabi ko, pwede nyo i-classify yung A4 into 3 conjugacy classes. Actually, nililista ko dati, yun yung conjugacy classes. Ito yung mga 3 cycles, no? Ito yung mga products of disjoint. Ito yung ABC. Ito yung ABCD. Tsaka yung identity. Iisipin nyo, sir, ba't hindi mo sinama yung mga 4 cycles? Ito, hindi kasi ito even. This is odd. Remember, ang A4, ang kino-consider lang natin yung mga even permutations. Ang bilang natin, 8 to. Ito 3. Ito syempre isa. Yung subgroup na tong V na tinutukoy dito, siya yung subgroup containing all the 3 elements of this conjugacy class and the identity. This form a subgroup isomorphic to. Saan nga isomorphic to? Ito. Which group is this isomorphic to? Order 1, order 2, order 2, order 2. Line form. Wala kasing element of order 4, so hindi siya cyclic. Isa lang ang choice mo. Klein form. Okay? All right. So why is this a normal subgroup of A sub 4? Madali. Alam niyo bakit madali? Kasi nga, elements in V sorry. Let me emphasize, non-ID elements of V are of the same what do you call this? Cycle type. Hence, they are conjugates to one another. Ibig sabihin yan, pag kumuha ko ng little v sa V, kumuha ko ng kahit na sinong G sa A4, sure tayo na ang G, V, G inverse is still an element of V. Kasi halimbawa, pag kinonjugate ko yung ID, anong conjugate niya? Sarili niya. Pag kinonjugate ko tong 1, 2, 3, 4, isa lang dito yan sa 3, wala nang iba. Pag kinonjugate ko ito, isa lang dito sa 2. Pag kinonjugate ko to, isa lang dito ulit sa 2. So they are just conjugates of one another. I don't have to even, diba? Ang kuha tayo ng epsilon sa A4. Yeah? Kunin mo yung epsilon A, B, C, D. Ano itsura na ito pag kinonjugate mo? Di epsilon of A, epsilon of B, epsilon of C, epsilon of D. Ito ngayon, element pa rin ito ng V. Hindi ka lumalabas sa loob ng V. Kaya si V is clearly a normal subgroup. Did you understand why this is normal? Ginamit natin yung lesson kanina. Diba yung about conjugates? Tingnan nyo, dahil alam natin yun, madali nang i-prove itong normality ng V sa loob ng A4. Kasi nga yung mga nasa V, basically aside from the identity, magkaka-type sila. Kaya they will be conjugates to one another. Pero halimbawa, may subgroup ka, may ganito ka, tapos may isa kang 3 cycle, no? Patay ka na dun. Malamang sa hindi, hindi yun normal. Pero wala namang subgroup ito na gano'n eh. Nilista natin yung lattice diagram nito dati. You can check. Tignan nyo kung sino yung mga subgroups doon that are conjugates of one another. You can check. Okay, do you have a question? Any question so far? None? Kung wala, please type 0. May tanong ba? None? There's none. Let's move on to the next lesson. Ay, sorry. Ano ba ito mali? Dali, hanapin ko yung susunod na lesson. Yeah. Sorry. This is the next lesson. We are now going to talk about quotient groups. But I think let's take a short break. Kahit mga ano lang, 5 minutes, 4 minutes. Diyan lang kayo ha. Or gawin nyo na yung mga thing ninyo. In 4 minutes, 5 minutes, 11:20, start tayo ulit. Okay? See you. Thank you. Bye-bye. So in the previous lesson, we defined what it means for a subgroup to be normal. So in the very basic sense, normal kung yung left and right cosets agree or if they coincide. Tapos, so the question is, why is it a thing in group theory? Bakit natin gusto na ang mga left at right cosets ay nagko-coincide? O may tanong, ano daw coverage ng quiz mamaya? I forgot, pero ano lang yun? Hanggang ano lang yun? Hanggang Lagrange theorem nga lang yata or wala pa? Lagrange theorem lang yata. Wala pa yung mga coset. Or meron yatang cosets. Pero basic lang. Wala pang normal subgroups. Kaya yung dinidiscuss ko ngayon is, today is sa mga susunod na quiz, sa susunod na quiz pa. Okay? Yeah. So in this lesson, pag-uusapan natin why is normality a thing in group theory. Ano bang benepisyo maliban sa parehas ang left cosets at right cosets? Kasi parang ano naman, no? Comparison left and right cosets. What? What did it do? Now, ang mangyayari kapag para normal ang isang subgroup, out of that given subgroup, makakabuo tayo ng another group structure. In other words, we can create another group structure using that normal subgroup. Sa bawat normal subgroup na may encounter mo, out of the group G, makakagawa tayo ng another type of group. No, ang tawag doon sa group na yon, we call it the quotient group modulo the given subgroup. So in order for you to realize this, let's start with an example as always. No, I normally do this thing with examples. And let's take a non-abelian one. This time the group D4. The group D4 again is the symmetry of the group of symmetries of a square. Kasi regular foregone. Okay? This has 8 elements. This is the rule. This is the group presentation, and this is the rule governing the elements R and S. No? So R is of order 4. So meron kang 4 na powers ng R. And then yung S, the other coset. Ito yung other coset. Ito yung 4 na mirror reflections and yung 4 na rotations. Here in the table, I have given you the table for D sub 4. The multiplication in D sub 4. We don't need to do this. Kung mapapansin nyo, ngayon lang ako gumawa ng table for D4 kasi the truth is we don't need a table to calculate products in D4. Just by remembering these formulas or these equations, kaya nating i-derive lahat ng mga products na yan, di ba? Agree? Do you agree? Yeah, we don't really need to do this table. But when you come to think of the table, meron kayo napapansin pattern in the table? Can you give me any observation? Any kind? Walang maling sagot. Sige, please, either on the chat box or through the microphone. Do you notice something about the table? Any observation that you can give?
Pwede mahati sa apat.
Yeah,
Parang may symmetry po na apat.
very good. Parang nahahati sa apat. That's a very good observation. Ano yung nahahati sa apat? Anong hati? Pag ganun? Charot. Hindi, actually, ang nahahati sa apat, yan. Yung nahahati sa apat, it means, mathematically, it means that product of two rotations is a rotation. Product of a rotation times a mirror reflection is another mirror reflection. Product of a mirror reflection and a rotation is another mirror reflection. And a product of two mirror reflections in this group is a rotation. So in short, in D sub 4, if you multiply two things of the same type, rotation, rotation, mirror, mirror, ang lumalabas sa sagot ay rotation. But if you multiply two of the different types, ang lumalabas naman ay mirror, reflection. So yun yung naging summary. In fact, yung nakita nyo sa table, it can be geometrically interpreted. To formalize this observation, you consider the subgroup H generated by R. The subgroup has 4 elements. Ito yun, yung apat na yun, di ba? Now, this group has order 4, kaya yung index niya in D4 is 8. Is 2. Kasi yung D4 ay, ano ba yung G? Yung G ay si D4, ha? Ang index ni H sa G, sa D4 ay 2 kasi nakalahati siya precisely nung group. So because this has index 2, it will have two distinct cosets. Normal si H, no? Kasi index 2. It will have two distinct cosets. H itself is 1. The other is just take any element. So tignan na lang natin yung right cosets kasi anyway, normal siya, no? So it doesn't matter kung left or right. One of the right cosets is H itself. In fact, ito yung HID, di ba? For your information. And the other coset is HS, yung di pa nababanggit. So which are the other reflections? Parang nasa isang coset lahat ng rotation, nasa other coset yung lahat ng mirror reflection. So as you can tell, ito yung nangyari. And what I want to say in this context is that parang yung group table mo can be collapsed into a more simpler table. You can say, nandito yung H, nandito si HS, nandito si H, nandito si HS. Ang lumalabas sa H times H parang H lang din. H times HS, HS, HS. Kasi ito ay H lang din. Parang the table can be simplified by simply putting it this way. Do you understand what I mean to say? Yeah. So in some sense, it looks like these cosets form a group structure. In fact, this forms a group structure isomorphic to Z sub 2. Para kung merong 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, at saka 1 plus 1 is equal to 0. It's like you're having such a vibe. Na? The question is, kung bumubuo talaga ng group yung mga cosets na ito, ang elements ng group natin yung mga cosets ng H, no? Okay. Kung bumubuo talaga ng group yung cosets na to, ang tanong, anong operation? How will you define that operation? Why is H times HH? Why is HS times HSH? Diba? Et cetera, and so on and so forth. So how will we define that operation? So in order to clarify that, let's try to look at another subgroup. Now this time, I want you to look at the subgroup generated by R squared. Now R squared, well, basically R is of order 4. Kaya ang R squared, ang order niya ay 2. Kasi dalawang R squared lang sapat na to generate the identity. Kaya ang ma-generate niya, dalawa lang, ID and R squared. This time, dahil ang K ay order 2, ang index ngayon ng K in G is now going to be 8 divided by 2. And that's 4. In short, this will generate 4 right cosets or 4 left cosets, whatever. Pero, do you notice that in fact K is normal? Even though sige, pakita natin. Why? Why is this? Why is this the case? Well, first of all, if G is a rotation, when I say rotation, I mean any of these ID, R squared, R cubed, then obviously GK is equal to KG. Kasi ang laman lang naman ng K, mga powers lang din ng R. Di ba? Eh, paano kapag hindi rotation yung G, sir? Halimbawa, S. Kung S naman, alam nyo kasi ang SR squared. Ano bang SR squared? Parang dito normal. Ay, hindi. Tama, normal. Kasi this is R to the 4 minus 2S. Nagkataon ng SR squared parehas sa R squared S. Right? Kaya, ang sabihin nito, ang SK mo, parehas lang yan sa KS. You just need to check for for the for R squared kasi yung identity nakikipag-commute naman with everyone. Diba? Eh, in short, si S nagko-commute with R squared. In short, everyone will commute with R squared. Kasi yung other elements will just have S as a factor. Do you agree? Because S itself commutes with R squared. R squared actually commutes with everyone. Nagko-commute siya sa ibang powers ng R, obviously. At magko-commute din siya doon sa ibang other elements which has S in it. Kasi si S itself, nagko-commute siya with R squared. So, now, would you agree with me when I say that R squared commutes with everyone? So therefore, because R squared commutes with everyone, lahat ng left cosets ng K, magiging parehas lang sa right cosets ng K. Do you agree? Sige. Please take time to think about it. No? Kasi si S ay nagko-commute. Kung meron kayong aalalahanin sa R squared, si S lang yun kung siya ay magko-commute with R squared. Kasi pag nag-commute na si S, all others will also commute with R squared. Okay? Yeah. So K is normal in D4. So you convince yourself, no, that K is actually normal. So let's just look at the right coset. Sabi nga natin, pag normal, you don't really have to look at the left and right coset separately because they will exactly be the same. So the right cosets of K are, of course, that's K. So pwede tayong mag-multiply ng R. Pag nag-multiply ako ng R on the right, I get R and R cubed. Lumabas na yung 4 na rotations. If I multiply an S, you get, saan tayo nag-multiply dito? S on the right, you get S, R squared S. Ang di pa nababanggit, si RS, if I multiply an RS on the right, I get RS and R cubed S. And there you have the 8 elements of K. Now, ito yung gagawin ko. originally we write the table in this manner kasi there is some order of this is basically according to the way we listed down the rotations and the mirror reflections. Kaya ganyan yung arrangement natin. Pero this time, tignan yung gagawin ko. Ang gagawin ko, i-rearrange ko yung mga elements in such a way na unang mag-a-appear yung elements ng K, and then second yung mga elements ng KR, third yung mga elements ng KS, and lastly yung mga elements ng KRS. So here you go. Ulit, ito yung original. If I rearrange, I will get something like this. Ito, no? To tell you kung ano nangyari, ito yung K, ito yung KR, ito yung KS, ito yung KRS, ito yung K, ito yung KR, ito yung KS, and ito yung KRS. Naintindihan ninyo kung anong ginawa ni Sir? I want you to now look at the table and kindly get some observations again. What do you notice? What do you notice? Do you notice something? Any observation is correct, so please tell me. Okay, sige, to lead you to something, let's look at the previous example. Ano nangyari sa previous example? Nagkaroon ng 2x2 blockings. Nagkaroon tayo ng 2x2 blockings kasi nga may dalawa kang cosets. Sige, this time, anong meron? Nagkaroon tayo ng 4x4 blockings. Right? Do you see that? Ang nasa iisang block are elements in the same coset. Yun yung rule. Makikita nyo, magkakagrupo yung mga nasa iisang cosets. Nice, no? But do you notice something? Furthermore, look at this. These blockings are now in this type. Parang kapag isa-summarize mo siya, ito yung coset na K, KR, KS, KRS, in-arrange sa table, it looks like the cosets themselves seem to form a group structure. No? If this has to be a group, no? If this is supposed to be a group, to which group is this isomorphic to? Can you please tell me?
Klein 4.
Very good. Oh, Klein 4. It's Klein 4, not Z4, huh? How did we know that this is Klein 4 and not Z4? Ang isang indication when you just look at the table is that. Why is this a Klein 4?
Diagonal po.
Yes. Ang isa sa mga indication na siya ay Klein 4, kapag nakita mo ang diagonal, lahat identity. You understand? Ang isang prominent feature ng Klein 4 table ay yung identity yung nasa gitna. Whereas ang Z4 kasi, ang Z4 or cyclic group of order 4, ang meron kang dalawang elements of order 2 kaya hindi laging identity yung gitna. Yeah. So when you look at this, Hindi siya laging identity. Unlike line 4, ito yung Z4, ito yung line 4. Ganyan yung pattern ha. Tatandaan niyo palagi yan. So this is line 4. So it seemed like the cosets themselves form a group structure. But remember, a group is not a set alone. A group has to have an operation. So the question is, what is the rule? What is the rule for multiplication among these cosets? Why can we say that they form a group? If they form a group, what operation is that in particular? So it seems like there is some sort of coset multiplication that we have to define in order to formalize all of this. So nakita niyo yung process? Ang process is this. Kukuha ka ng isang subgroup. Tapos, kukunin mo yung mga cosets nung subgroup na yun. And then, yung mga cosets na yun bubuo ng parang group lang din. The question is, does that happen all the time? Does that happen all the time? Let me create a smaller example. Let's work on D3 para hindi naman mahirapan si Sir ha. IDR, R squared, para 6 lang. Ano to? S, RS, R squared S. Rules of the game, R cube is identity. S squared is identity, ang RS ay ang SRI R squared S. Okay, so these are the rules of the game. Let me take the subgroup K generate let's not use K, let's just use H. Generated by S. This time it has I2. This time makikita nyo, H is not normal. Kasi, alam nyo, ang RH ay RS, whereas yung HR ay IDSR. Ang SR kasi nagkataon, R squared S na kasi. So, they are not the same. No? Now, let's get the left cosets na lang. We could have taken the right cosets instead, but let's just take the left cosets of H. So the left cosets of H are, of course, H. We could have RH. Nilista ko na. Sana pala, tinipe ko na rin ito. Anyway, kalimutan ko. What's the other coset? Kasi index 3 yan. Kasi 2. 6 divided by 2 is 3. What's the other coset? How would you name the other coset? How would you name the other coset?
R squared H.
Yeah, R squared H. R squared is not yet mentioned. Yeah. So this is how we do that. Now, let's look at the table this time. Pero this time, yung table na ito gagawin ko in accordance to how we write the element. Magkakasama yung mga nasa same coset. ID, S, R, RS, R squared S. Of course, this is ID, so let me just put it here like so. RS, R squared, sorry, R squared S. S times S, identity. S times R, R squared S. S times RS, R squared SS, that's R squared. Bilis ko, no? SRS is R squared SS. SS will cancel. Okay. SR squared will be RS. Check ha. SR squared is RS. So SR squared S is RSS or R. Sige, gagawin ko na sa inyo kasi mauubos na yung time natin. R squared S. R cube is identity. R cube, so that's S. RSS is R. RSR is RR squared. So RSR is S. This is identity, identity, identity. Kasi mga mirror reflections yan. RSR squared. Anong RSR squared? RRS. R squared S. R squared. Hindi nawawala. Ano na to? Sudoku property na lang ito. Ano yung nawawala dito sa last column? RS is missing. Okay. This is R squared S. This is R cubed. This is R cubed. So S na lang. Sudoku property na lang ito. Ano nawawala sa second column? Hindi ko makita. Ito. R squared. Ano nawawala sa third column? Shit. Ano nawawala?
Identity.
No. There's something wrong here. Aha. Identity. Mali ako no? Okay. Alam ko na yung mali ko. Alam ko na yung mali ko. Shit. Ang R squared, nagmadali kasi si Sir eh. Ang R squared ay R. Di ba?
Ay, sir, may R cube ka dun, no? Sa R squared R. Din dapat yung identity.
Itong dapat identity. Ang sakit sa bangs. R squared R, okay. Tapos, okay lang ba na identity to? Hindi no? Kasi magbabangga yung dalawang identity. So ano yung nawawala dito sa third column? RS.
Yung RS.
Okay, yan. Okay. Next, ano nawawala sa fourth column? R is missing. Very good. Ano nawawala sa fifth column? S. I guess we're fine. This is now the table. Okay. Ang gagawin natin, ikakahon natin yung mga magkakasama sa same coset. Ito yung same coset. Diba? Ikakahon ni Sir. Ganyan. Hindi, yan. And then i-identify ko sino yung mga magkakasama. Ito okay to find. Magkakasama ba yung RRS? Ay, naku, hindi. No? Ito yung sinasabi ko. Ito, magkasama. Pero ito, hindi. Yung R squared S at R squared magkasama. Pero nasa ibang coset sila ng R and RS. I have to compartmentalize this table this way. Parang yun yung sinasabi ko. Ganyan. Tapos ito naman magkakasama, fine. Ito rin magkakasama. Ito magkasama pero ito hindi. Ito magkasama, ito kasama. Yes. So this is a mess. Pwede ba spelling ng mess? Apa ba spelling ko ng mess? It's such a mess. Bakit naging mess? Parang wala lumalabas dictionary. Okay. Tama. Why is this such a mess? Hindi nag-blockings, no? Hindi nangyari yung ini-expect nating mangyari. Nagkalabo-labo. Halimbawa, yung product ng dalawang cosets na ito, hindi mo mailalagay sa iisang coset lang yung product. And that is not so nice. Hindi nagkaroon ng blockings as intended and as we wish. And why do you think that is the case? Anong hula nyo? Bakit hindi nagkaroon ng blockings dito unlike before?
Hindi kasi normal.
Yes. In fact, that's the point of this lesson. Kasi yung ginamit kong subgroup ay hindi normal. So alam niyo na bakit interesado tayo sa mga normal na subgroups? Kasi they will form cosets, and then these cosets will form blockings of the original group, where these blocks themselves form another group structure. Yung group structure na nabubuo ng mga blockings using normal subgroups are called the quotient groups. Ayun yung tinatawag na quotient groups. Alam niyo ba't quotient? Hinahati-hati. Nakuha niyo? In fact, that's the summary of this lesson. Wala pa tayo dun sa definition, but that's the summary. We can form another group structure by partitioning the group into cosets of normal subgroups. No, yun yung idea. Kapag hindi kasi normal lang kinuha mo, something not so nice will happen. Hindi magkakaroon ng magandang blockings just like before. So at least now, you know it. But the question is, if let's say we pick a normal subgroup, we pick a normal subgroup, how would we define the operation if we want this to be a group? Halimbawa, ano yung rule? Bakit ang KR, KS naging KRS? Ano yung rule? Bakit yung KRS times KS magiging KR? How will you define that? How will you give meaning to that? Ang tawag natin dyan ay coset multiplication. And how do we define coset multiplication? This way. Okay? So, if you take an arbitrary subgroup H of the group G, two elements A and B of G, the coset AH, when it's multiplied the coset BH, we define it as the coset containing the product AB. Minumultiply mo sa A and B as if they are elements of G. Kung sino man yung coset na nagko-contain doon sa product ng A and B, yun yung coset product ng AH tsaka BH. And of course, in a similar manner, pwede ka rin mag-define ng right coset multiplication kung kaya mo mag-define ng left coset multiplication. In pictures, imagine niyo ito yung group. Imagine niyo ito yung si G. Ito kunwari yung subgroup H. Ang gagawin niya yung H na nahahatiin niya yung group into several copies. Pero they're not exactly the same copy, no? Kasi cosets yan. Kunwari ganyan. Hinati kunwari ni H si G into 5 copies of itself. Actually, hindi siya copies. You can say translates kasi parang tinatranslate mo si H by an element, no? To get the other cosets. Ano ba? Ito si A1H. Huwag na natin pakalanan. Basta kunwari may 5 coset si H sa G. Ganyan ang itsura niyan. Pagkatapos, dahil subgroup yan, sabi ng Lagrange theorem, dapat divisor si H, nung order ni H, order ni G. So, magkakasing size yung mga cosets na yan. Kung anong size nung subgroup, ganun din yung size ng mga cosets. Paano ginagawa yung coset multiplication? Halimbawa, nandito si A. So, itong coset na siya si AH. Understand? Siya si yellow coset. And then you get another element. Let's say itong element na to. Kunwari nandito si B. So this coset is named BH. So we have the yellow coset. We have the red coset. This is the coset BH. This is the coset AH. Now, look at the dots A and B. They are elements of G. So, as elements of G, pwede mo silang i-multiply. Meron kang product na AB. Kunwari, ang lumabas, si AB nandito sa coset na to. Kasi ang mga cosets, partition yan eh. Diba? So, yung AB na matatagpuan mo sa possibly ibang coset. But definitely, yung blue na coset na yan, yung coset na yan that contains AB, kung kukulayan natin siya ng blue, Ito siya, no? Yung ABH. Yung coset na yan yung ibig sabihin nating coset product ng AH times BH. Ganyan, no? Parang ganyan yung ating magiging definition. Did you understand? Coset multiplication in the basic level or using this illustration, do you understand it? Parang ang elements natin, parang ganito, yung group mo, ginugupit-gupit mo into pieces, na? Parang gawa sa papel yung group mo. Pupunit-punitin mo siya into pieces where each piece is a coset. Ang element ngayon ng group na binubuo natin, yung mga cosets mismo, parang yung elements mo are actually sets. Gulo, no? Parang yung quotient group, parang set of sets. Naiintindihan ninyo? That's why students normally are having difficulty understanding pag nandito na sa lesson na to kasi it is becoming more and more abstract. Parang elements ng group mo yung mga subsets na ito, mga pieces, right? Parang isang element to, lahat ng mga elements nandito kino-consider mo as a one point. Lahat ng element na nandito ina-identify mo as another point. Lahat ng elements dito ina-identify mo as another point. And so on and so forth. Did you understand? Okay. Sa ibang subject, for example, sa topology, yung quotient space na mas general, para kang nag-glue, ginuglue mo. Paano ginuglue? Parang lahat ng mga elements na to are glued together. Ginuglue mo sila together. Ginuglue mo rin together yung mga group, yung mga points na yan. Ginuglue mo yung mga points na together and so on. Nagkakaroon ko lang ng 5 points ngayon. Yung 5 points na yun, yung bagong space mo, ang tawag doon yung quotient group or yung quotient space in this case. Okay? But you know, there is some complication to this definition which I would like to share now. Kaya lang 3 minutes. Kaya pa ba? Sige, kaya. I will show you the complication of this definition. You cannot just define a coset multiplication actually. There will be a problem. What will be the problem, sir? Let's look at this. Consider the subgroup H of D4. Okay, dalawa order 2 yan. Ito yung coset na RH. It contains R and RS. As you can see, because RS is here, this is also the coset RSH. Okay? So equal yung RH sa RSH. When you look at the coset R cube, containing R cube, that's the coset R cube S. Minultiply yung R cube dito sa kaliwa. Because R cube S is also here, it could also be represented by R cube S. No? Parang itong mga nakikita nyo dito, sila yung mga representative ng bawat class. Okay? Mga kapatid parang representative. Imagine mo siya yung panganay. Sabi ng isa, pwede rin naman ako mag-represent di ba? Parang ganun. By definition of coset multiplication, if I multiply these two, ano lalabas? R times R cube, identity. Yung identity nasa H yun. Kaya yung coset na to is just H. And H is the set ES. Correct? Do you follow? Do you follow with this multiplication? Nasundan nyo? Now look at this. Di ba ito parehas lang to doon? Ito parehas lang to doon. Kapag minultiply ko ngayon to, gamit yung rule, hindi mo multiply mo ganyan. Kapag ito sinimplify nyo, sige, simplify natin. RS, R cube, S. Yung S, R cube muna, that's RS. Kasi 1 plus 3 is 4. RS yan. So, ang SS identity, R squared ang lalabas. At ang R squared H is now the set R squared S. Ano nangyari? Ang nangyari ito po. This means that the product RH R cube S is not the same as the product RSH R cube SH even when these two are equal and these two are equal. Weird yun. Bakit ito weird? Sorry na ha. 1 minute. Give me 1 minute. Weird ito kasi parang sinasabi natin, meron kang A equal kay B, C equal kay D, pero ang AB hindi parehas sa BD. Ay, sorry. Ang AC hindi parehas sa BD. Parang ganyan yung nangyari. And algebraically, this is weird. Hindi dapat mangyari yan. Ito yung complication na sinasabi ni sir. So the quotient multiplication can sometimes be weird, just like in this example. Alam niyo kung ano naging reason ng weirdness? Again, ang reason, si H ay hindi normal. Kasi ang next na theorem natin, ipoprove natin na yung weirdness na yan hindi mangyayari had we chosen a normal subgroup. Kung ang pinili mo ay normal na subgroup, hindi mangyayari yan. Kapag ang AH pareha sa BH, CH pareha sa DH, i-imply niya na yung ACH pareha sa BDH. Yan ang isa sa mga nagagawa ng normality na hindi magagawa ng simple na subgroup lang na hindi normal. Okay? With that, putulin muna natin yung lesson and I hope nag-gets nyo, nakakasunod kayo sa storyline. Okay? Stop ko na yung recording ha.